निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students, today we will be dealing with the chapter number 10, that is circles, from your NCERT textbook class 10 mathematics. We will be dealing with the introduction and solution to the exercise 10.1 also. What is a circle? We have gone through this term circle in almost each and every class that we have gone through in our previous classes, starting from standard 4, 5th, 6th. Circle, shapes, circle, shape, a circle is a shape, and circle, circle and circle. Our teachers used to say that whenever we ask what is a circle, they used to draw. See, this round shape is called a circle. And they were perfectly correct, they were not wrong. But here in higher classes, class 9, 10, we cannot say like see this round shape is a circle. That's a wrong concept. We cannot say like that. That means there might be some particular definition for circle. In higher classes, we normally say what is a circle means. A circle is a set of all the points. A circle is a set of all the points whose distance from a particular fixed point is always same. Let me repeat the definition once again. It's a set of all the points whose distance from a fixed point is always same. Fixed point? Where is the fixed point? That fixed point is the center of the round shape that our teachers used to say. So this is our fixed point. This is the center. And set of points? Where are the set of points? The set of all the points are all those points that lies here in each and every place on the shape that our teachers used to say. There are infinite number of points. Again, moving on to the definition, the set of points whose distance from the fixed point, distance means this distance, this distance, this distance, 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 for all infinite number of points. This distance is same for all the points in the set. If we consider all such points whose distance from a fixed point is always same, then we get this round shape that our teachers used to say. So, moving on to the definition, it is the set of all points. Set of all points whose distance from a fixed point is same throughout. This is a sort of, you can say, an explanation or a definition for circle. Set of all the points whose distance from a fixed point is same. Then we get the shape of a circle, that round shape. Now let us take once again. Now we have a circle whose fixed point is what we call it as center, and the distance, that fixed distance, the distance that is fixed, that distance is called the radius of the circle. This is the radius of the circle. The distance from the center of the circle to one of the fixed points is termed as a radius. If you double the radius, if you move this way, so let us draw some different way, this one. Twice of the radius, then this line will be my diameter. This distance will be my diameter. This is called the the diameter of the circle, where now a relation can be developed between the diameter and radius of the circle. Is diameter is twice of the radius. In short, mathematically we write B is equals to 2R. This is a small relationship between diameter and radius. There are various terms related to circle. We will be moving one by one. We will be trying to cover almost all the terms. Suppose we are given with a circle, and suppose this is the line that is intersecting the circle at 2 points, point A and B, and this is the line, say P and Q. What do we call that line? Which line? AB or PQ? Let us talk about both. What is AB? AB is said to be the chord of the circle. Chord of the circle. Then how many chords can be drawn in a circle? There are infinite number of chords possible to draw on a circle. A chord is a line at exactly 2 points, touching 2 points of the circle. It's a line, it's the distance between the 2 points and not the PQ. Then what is PQ? PQ is called the second of the circle. Second. That is PQ is called second of the circle, and AB is called the chord of the circle. Number of chords can be drawn this way, this way, this way, this way, this way, this way, this way. Infinite number of chords can be drawn on a circle, and for each chord we will have infinite number of seconds, because a chord is a part of a second. Then which is the longest chord that is possible in a circle? Yes, that is the diameter of the circle is the longest chord of a circle that is possible. Now, let's again move to another figure. If this is the chord, this is my center, then what is this part? This part is called the segment of a circle. Segment of a circle. This is the region between the arc of the circle and chord of the circle. So this is my chord of a circle, this is my chord of a circle, and you can say this one is the arc of a circle. Arc of a circle, this total is considered to be an arc. This part of the circle is a smaller part of that arc. So we call this one as minor arc. And this arc will be major arc. Similarly, the region between the chord and the minor arc, what we term as a segment. So this is my actually minor segment. Then, and the distance, sorry, the region between the chord and the major arc, this part, this is called my major segment. Let us take one more figure. One more figure, let us see. Another term related to the circle. Suppose this is my circle, this is my center, and we take 2 radius at a time. Again, there are areas enclosed between the 2 radii. This is one part of the area of the circle, and this is another part of the area of the circle. Now, what do we call such areas? Now, this type of area, this shape, what we call it as this way, which includes 2 radius and an arc of a circle. So, the area enclosed between the 2 radius and an arc of the circle is termed as sector. And since this is a smaller part of the circle, we call it as minor sector. And the remaining part, apart from this, what part is left out? This way. This part is left out. Again, as I have told you, the area enclosed between the 2 radius and the arc, that is called sector. Here the arc was minor arc, so it was minor sector. Here the arc is a major arc, so this total area is termed as major sector. These were some of the terms that were actually related to circles. One most important term that we want to go through in class 10 is a word called tangent. As we have discussed in the previous figures, that there are different types of lines that are crossing the circle. That is, second, it was intersecting the circle at 2 points. You can say chord even, that is intersecting the circle at 2 points. But there are certain lines which are intersecting the circle at one and only 1 point. Such lines are called tangents. How they are? Suppose this is our circle, and there is a line that is touching the circle at only 1 point. Say this way. It is touching the circle only at 1 point. Let's say this line is PQ. Such lines which are intersecting the circle at only 1 point is called my tangent. So here we can say PQ is the tangent of the circle. Tangent of the circle with center O. We can also have tangent this way. Suppose one more line here. This is 1 point. And this is my line, say AB. So AB is also the tangent. Then how many tangents are possible in a circle? There are infinite number of points on the circle. The definition of circle itself says that it is a set of all the points whose distance from a fixed point is same throughout. That means all the curve of the circle, there are infinite number of points, and for each point we can have one tangent, as tangent is a line that touches only or intersects only 1 point of a circle. Being infinite number of points on the circle, infinite number of tangents are possible on the circle, or a circle can have infinite number of tangents. So far we had discussed these all terms. First of all, the circle, as our chapter was, what is a circle? That fixed point of the circle was termed as the center of the circle, and the fixed distance between the center of the circle and each point on the circle was termed as radius. Then we had discussed the diameter of the circle, that was twice of the radius. Then we discussed second, it's a line passing through the circle, intersecting the circle at 2 points, that we call it as second. There are infinite number of seconds. Then we discussed chord, a part of the second which lies within the circle at their 2 points, at their 2 intersecting points, that is chord. Infinite numbers of chords are possible in a circle, that we have discussed. We discussed regarding segment, that is the region between the chord and the arc of the circle. That is, if it's a minor arc, we call it as minor segment. If it was major arc, we call it as major segment. Then we discussed regarding sector. It is the region between the 2 radius and the arc of a circle. Again, depending upon the arc, if the arc is a minor arc, we call it as minor sector, and if it's a major arc, then we call it as a major sector. We discussed about the arc, that is the total boundary of the circle, dividing it into 2 different parts, minor arc and major arc. And if we are talking about the arc on the diameter, if the diameter is drawn, then we will have 2 equal arcs. Moving on further, we discussed regarding tangent, that it is a line that is touching the circle at only 1 point. That is, this line, if it intersects the circle at only 1 point, then such line is called the tangent of the circle, and the point at which the tangent touches the circle is called the point of contact. This was considered to be the point of contact. So far we have discussed the terms related to the chapter circles. Moving further on to the chapter, let us discuss the first theorem, that is theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. That means we are given with a circle with the center O. Suppose we are given with a circle with center O, and the tangent at any point of the circle, say the tangent be this one, at any point of the circle, let that tangent be PQ, and that point of contact at any point which was called, that is named as, say, M, and the tangent at any point of the circle, is perpendicular to the radius. That means if this is joined, then this will be OM will be perpendicular to PQ, as the theorem says, at the point of contact. So we need to prove that OM is perpendicular to PQ if PQ is a tangent of a circle. So let us prove the theorem. We are given, what is given to us? A circle with center O. What we need to prove? We need to prove that OM is perpendicular to PQ. This we have to prove. For this, what did we do? So we can say in the form of construction, we have joined OM, and then the proof. These are the 4 steps that we will have to always follow while proving any of the theorems or any of the sums in the chapters of circle, or any other chapter where theorems or proofs are asked. You always need to follow such things. You will have to write, given what is given in the question, you will always have to write to prove what is to be proved in the question. If required, construction is to be written. If not required, this is not required. And the proof part, how are we proving the theorem or the question. So let us now move on. According to our theorem, we are given a circle with center O. We need to prove OM is perpendicular to PQ. For that, we joined OM, and now we will be proving how OM is perpendicular to PQ. Let us consider any point on PQ apart from M. We can take any point on PQ apart from M. Why can't we take, suppose we take the point here as M and join OM, and join OM. Let us join OM. Why we are taking M, a point on the line PQ? Because we want to prove that OM is the shortest distance. If OM is the shortest distance, then we know that the shortest distance from a point to a line is its perpendicular distance. So first of all, we need to prove that OM is the shortest distance. If OM is the shortest distance, it is naturally perpendicular to the given line from an external point O. So in order to prove that it is the shortest distance, we will have to check that the other distances are greater than OM. For in order to find other distances, we need other points on the line PQ. That is why we took a point N on PQ. Now if we see very clearly, ON, the line, that point N lies outside the circle and M lies on the circle. That means ON is greater than the radius of the circle, as OM was radius. If ON is greater than the radius, that means ON is greater than OM. Let's write this much first. We have joined ON. Now, in triangle OMN, it is clearly visible that ON is greater than OM. ON is greater than OM. Similarly, moving and taking different points. Similarly, taking various points. PTS means points. Taking various points on line PQ. In each case, we will get that the line from center to that point, from center to that point will be greater than OM. You can take N if you want to take, you can take one more point, say R, you can take one more point, say Q, sorry, Q has already been taken, you can take say T. So if you join OT, OR, all will be lying outside the circle. That means OT, OR, OM, all are greater than OM. That is, OT is greater than OM. You can say OR is greater than OM. So, in general, we can say OM is the shortest distance. And if it is the shortest distance, then we know that the shortest distance from the point to a line is always perpendicular to the line. So we can say OM is perpendicular to PQ. That is. Let us move once again to the theorem. It's a very important theorem for the chapter. We are given with a tangent intersecting the circle at one point, at the point of contact M. We need to prove that OM is perpendicular to that tangent. For that, we have taken a point on the line PQ as N, and we have seen that point lies outside the circle. That means ON is greater than OM. And if we go on taking such points on the line as D, R, in each case we will see that all the points lie outside the circle and all the distance from the center to that point would be greater than OM. That means if we might have taken D, this is OT is greater than OM. We might have taken R, then OR is greater than OM. In general, we can say that OM is the shortest distance. Therefore, we can say the shortest distance from a line to the point is always perpendicular. So we say that OM is perpendicular to PQ. Now, exercise 10.1, the solution to exercise 10.1. We will be starting from question number 3. As question number 1 is a small question where it was written as how many tangents can a circle have? And there are some fill in the blanks that we had discussed in the introduction part. Let me just revise that once again, that there are infinite number of tangents possible to a circle, as a circle is made up of infinite number of points. The longest chord is the diameter, and a circle can have infinite number of chords also. The point of contact is the point where the radius of the circle and the tangent meets. That is the area between the chord and the arc of a circle is the segment. And so on, this all we have discussed in our introduction part. So we will be directly moving on to the question number 3 of exercise 10.1. So question number 3 is a tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ is 12 cm. Find the length PQ. So let us first of all draw the figure. What does the question want to say is, we are given with a circle with center O. A tangent PQ at a point P of a circle. So we are given with the tangent also at a point P, as I think, of a circle of radius 5 cm. So if you join this radius is 5 cm, meets a line through the center O at a point Q so that OQ is 12 centimeters. So the point might be here, that is Q. So we can say that this is a tangent PQ at a point P of a circle, the radius 5 centimeter. This radius meets the tangent, meets the line PQ at P such that OQ is 12 centimeters. So from here the distance is 12 centimeters. We need to find the length PQ. We need to find the length PQ. Now before solving this, we see a triangle is formed OPQ, and as per our theorem of 10.1, the radius and the tangent, they are perpendicular to each other. We have just proved the theorem that OP is the shortest distance of the point O to the tangent and OP is perpendicular to PQ. We can write OP is perpendicular to PQ, that is by theorem. Just we have solved 10.1. When this is perpendicular and it forms a triangle, it's a right angle triangle. So by using Pythagoras theorem, we can very easily get the value of PQ. So let us apply Pythagoras theorem in triangle POQ. So this can be written as PQ square plus OP square is equals to OQ square. That is, the sum of the squares of the two sides is equals to the square of the third side as per Pythagoras theorem. So PQ square we are looking for, we are to find PQ. So keep PQ square as it is. OP square is 5 centimeter, the radius of the circle that is given to us as 5 square, and OQ is equals to 12, that is also given in the question. So this is 12 square. So PQ square plus 25 is equals to 144. So PQ square is equals to 144 minus 25. This is 119. So we can write PQ is equals to root under 119. So this is the value that we have got for PQ using Pythagoras theorem, that the value of PQ is root under 119. So this was an MCQ question where 4 options were given to us, and according to our calculation, the option D is the correct one. So we can tick that option D is correct. So the length of PQ is root under 119. 4. Draw a circle and 2 lines parallel to a given line such that one is a tangent and the other a secant to the circle. It's just we have to draw it and we have to show it. For that we are given with 2 things. We are given with a circle, so that means we will have to draw a circle, and in the circle we are given with a line. Suppose this is our circle and it is given a line. Line can be anything, you can take a chord also. That doesn't matter. This is the center of the circle and we are given with a line. Suppose say this is a line. So AB is the given line and we are given with a circle center O. We need to draw 2 lines parallel to this given line. Out of the 2 lines, one is the tangent and the other is secant to a circle. So we will have to just draw it and show it that we have to draw a tangent and a secant. And what is a tangent? A tangent is a line that intersects the circle at only one point. So we will have to find that point and we will have to draw it. Presently we don't need to move out for any construction work. We will be just drawing and stating that this is a line. So if this is a line, let us draw a line this way, and this is a single point where this line, let us name it as CD, such that CD is parallel to AB, and this point, let us name it as P, is the point of contact, and CD is the tangent which is parallel to the given line. The second line that we need to draw should be a secant to the circle. So a secant is a line that passes through the circle, intersecting the circle at 2 points. So we can draw anywhere and any size. Suppose say this is parallel to this. We have drawn such that this is parallel to this. Name it as E and F, and E and F is termed as the secant of the circle as it is intersecting the circle at 2 points. This is 1 and this is 2. So we need to just state it that the given line is AB and we have taken the tangent to be CD. Our secant is EF, and all these 3 satisfies the condition that AB is parallel to CD, parallel to EF. So we have drawn a tangent, a secant, parallel to a given line AB of a circle with center O.